All right, lesson 5.3, factoring higher powers. So we're going beyond quadratics. So little review, okay? And we're gonna do this a lot, so we're gonna check it real quick. So these are 1, which is a perfect square, 1 times 1. 25, 49, 9, 4, 9, 100, all perfect squares. This is the easiest factoring there is, okay? You just take the square root of the first term, square root of the second term, 1 plus, 1 minus. Square root of the first, square root of the second, 1 plus, 1 minus. This one a little bit different. This one has 2x because square root of 4 is 2, square root of x squared is x. Square root of the second. And it doesn't matter if you put minus first or plus first. It doesn't matter. Okay? And then here again, 3x, 3x, square root of the first, 10, 10, square root of the second, 1 plus, 1 minus. That's it. All right, now we're talking about sum and difference of cubes. So we're going to use a little acronym called SOAP. It stands for same, opposite, always, and it would help if I could always spell. Always positive. Same, opposite, always positive. Now, what you're going to do is you're going to break this down to a binomial and a trinomial, each one. All right? And you're going to take the cube root of each, just like on the previous page, we did the square root of each. We're going to take the cube root of each. Okay? We're going to square the first. Okay? We're going to square the last. And we're going to multiply the two terms. And here's where the SOAP part comes in. So this was positive. So same, opposite, always positive. This was a subtraction. Same, opposite, always positive. Now let's see it with real numbers. All right, 8 and 125 are both perfect cubes. 2 times 2 times 2, 5 times 5 times 5. So we're going to have a binomial and a trinomial. You can even work backwards. You can do the SOAP part first. Same, opposite, always positive. Doesn't matter. So the cube root of 8, the cube root of x cubed, cube root of 5. Again, just like on difference of squares where we took the square root of both terms, here we're taking the cube root. Now you're going to square the first term. So that means this, 2x times 2x, which is 4x squared. You're going to square the last term. Why is it always positive? Because that number squared will always be positive. And then you multiply these two, a and b. So 5 times 2x is 10x. Don't worry about thinking, oh, well, it should be negative. No, it's same, opposite, always positive. Right? Binomial, trinomial. Cube root, cube root. All right, 3x times 3x, 9x squared. This is how I'm doing the numbers first, and then I'll put in the SOAP. All right, 7 squared, and then 7 times 3x, 21x. It was plus, same, opposite, always positive. That's it. Very simple. All right. Difference of cubes, binomial, trinomial. Cube root, a squared, b squared, a times b. Same, opposite, always positive. Binomial, trinomial. Cube cube root, cube root. Square them. Square it. Multiply. Same, opposite, always positive. Okay? Looks a little bit different. Usually we have the big number at the end. No big deal. This is still 1 times 1 times 1. Okay? So we have cube root, cube root, cube root. Square it. So that means 6x times 6x. Square it. Multiply them. Same, opposite, always positive. Now, a little bit different here. Let's step back, okay, and I want to do something different. X squared, x5 negative 6. x5 negative 6 minus 5. So let's do x squared minus 5 minus 6. Sorry, 5x. Let's pretend we're going to factor that. We need two numbers that multiply give me 6 that differ by 5. Well, that's 6 and 1. I want more negatives than positives. And there you go. It's factored. You're going to factor the exact same way. Now notice, this is 1. These are both 1. Here's the trick. We're going to factor it the exact same way. This is a 2. These are both going to be 2. And we're going to factor it the same way. 6 and 1. I want more negatives than positives. Because look, we can check it with multiplying. X squared times x squared is x to the 4th. 1x squared, negative 6x squared. Does that give us negative 5x squared? Yes. And negative 6 times 1. Check. If you're not sure if you factored it right, go back and check it. So we're going to treat this the same way as factoring a quadratic. Don't be thrown off by the 4. This is a 2. These are both 2. Now I need two numbers that multiply give me 40 that differ by 6. So again, two numbers that multiply give me 40 that differ by 6. And that's going to be 10 and 4. Now I want more positives than negatives. Okay? Now, in this case, we're going to go one step further. Now, both of these have something in common. Now, when we look at this, we know, whoops, don't know what happened there. We know that this is a difference of squares. Okay? So we're just going to keep the x squared plus 10. But this has got a factor 2x plus 2, x minus 2. We have to look for that. All right? Very simple. Again, it's a difference of squares, square root of each term, 1 plus 1 minus. Very simple. Here we have a new concept. Now that we've learned in chapter 4 about imaginary numbers, we can break this one down also. This is called a sum of squares. Guess what? We're going to do the exact same thing. Square root, square root, square root, square root, 1 plus, 1 minus. But then you might notice, and you say, Mr. Gilbert, that's going to give me x squared minus 1. And you are correct. So we're going to add I. Let's see what happens. X times x is x squared. I get negative 1ix plus 1ix. Those are going to cancel each other out, so no big deal. That's why we do 1 plus 1 minus. And then here, we're going to get positive times a negative, 1i squared. And what does I squared always turn into? A negative 1. Negative times a negative is positive, and that's why we end up with x squared plus 1. So that is a sum of squares. So I want to do one more of those real quickly. Let's take x squared plus 25. We know if it was minus 25, it would just be x plus 5x minus 5. And guess what? it's going to be the same thing. X plus 5, x minus 5. You just have to remember, when it's a plus, to tack on an I, and you're done. It's difference of squares with one extra step. That's all it is. No big deal. All right. Similar idea here. We're going to factor this the same way as if this was 4x squared plus 10x minus 6. First thing we're going to do is take out the common GCF, okay, which is 2. So that's going to make it 2 times 2x to the 6 plus 5x cubed minus 3. Same thing over here would be 2x squared plus 5x minus 3. So let's back up and do it the old way. This makes it much easier because this has to be 2x and 1x. 3 has to be 3 and 1. It's just where do they go? So if I want 5, if I put the 3 here and the 1 here, and they're going to differ, now you got to be careful here because they differ by 5. Here, they add up to 5. And if that was a plus 3, this is the way we would factor it. But right now, they have to differ by 5. And these two differ by 1. So that doesn't work. And these are one of those tricky ones where you have to be extra careful because the wrong way does look good if you don't pay attention to the signs. So here I want 3 and 1. That'll give me 1, that'll give me 6. All right. I want more positives than negatives. So this is going to be positive, that's going to be negative. So remember the little trick from before. This was a 1. These are both 1. Same idea here. I'm going to break this down. It's going to factor the exact same way. 1 and 3, negative and positive, the exact same way. The only difference is, since this is a 3, these are both going to be 3. Because x cubed times x cubed will give me x to the 6. And when I combine the middle terms, I will get that. All right? So the really trick is, if you notice, you're really just doing half of that. Or even easier trick, whatever that exponent is, that's what you're going to use as the exponent of each parentheses. Let's try it again. This time with 4. Okay. Again, we're pretty easy because this has to be 3x and 1x. There's really no other way to do it, except it's going to be x squared, remember, because that's a 2. Now, I just have to try. Remember, they're going to differ by 7. Okay, so I'm just going to do 5 and 2. 5 and 2. That gives me 5. That gives me 6. Okay, they do not differ by 7, they differ by 1. So let's try reversing it. 5 and 2. That gives me 2. That gives me 15. That didn't work. So let's try 10 and 1. That's really the only way to go now. 10 and 1. That gives me 10. That gives me 3. Oh, 10 minus 3 is 7. And since I want more positives, that's positive and that's negative. But remember, always check, can I go further? Remember how we reviewed difference of squares at the beginning, so you're going to use it a lot? Hint, hint. 3x squared plus 10 times x plus 1, x minus 1. Difference of squares. Now, if you have 4 or more terms, we're going to factor by what's called grouping. Okay? You can read through this yourself. You can hit pause. I'm just going to get right into the problem. But if you want to stop and read it, you can. So, here's what we're going to do. Okay? We're going to group them. Now we're going to take out the GCF. What goes into 5 and 10? 5. X cubed and x squared? X squared. Now, 5 divided by 5 is 1. X3 divided by x2 is x to the 1. Don't have to put that if you don't want to. Minus 2. And the x squareds cancel. Now, here's the thing. You can get to cheat on this. This has to be the same over here. And now you just ask yourself, what do I take out of here to get x minus 2? and that's a 3. This really helps working backwards so you know whether to take out a positive or a negative number. But this will give me 3x minus 6, so positive. And now all I do is put these two together. 5x squared plus 3, and I only write the x minus 2 once. Now, let's see where this comes from so you understand why. You don't have to write this down unless you want to, but watch. Please watch, don't skip. If I multiply these two, I'm going to get 5x cubed. Look familiar? And then I'm going to get negative 10x squared. And then I'm going to get 3x. And then I'm going to get negative 6. Okay? It is just the last step in multiplying before we combine like terms. So, when there usually is like terms. In this case, there are no like terms to join, and we still have 4 terms. But often when we do a binomial times a binomial, we get 4 terms, and then the middle 2 terms join together. In this case, since the exponents are different, we don't join in the middle. But that's where it comes from. All right, let's try it again. Group these two. Group these two. That's a plus. I had to put that plus there. Now, what comes out of 4 and 3? Nothing. Just 1. So I'm going to get x squared taken out. 4 divided by 1 is 4x plus 3. 3x squared divided by 1x squared. Now, again, this has to be the same, 4x plus 3. So what do I take out of here to get this? Some of you might go, well, 4, that's easy, but you got to think about the sign. Right now, this will give me positive 16x, and I want negative. Okay, I hook these two up. X squared minus 4, bells should be ringing in your head right now. And then I write 4x plus 3 only one time. This, though, goes further. It's a difference of squares, which, like we said, is going to occur a lot. And that's it. All right. Group them. Take out what you can. Divide. 5 divided by 5 is 1. X cubed divided by x squared is 1x. 15 divided by 5 is 3, and the x squared is canceled. Now, this is a tricky one. I need x plus 3. You might go, well, it's already there. Right, but I still need a number here. That's plus 1. Because I have to have something to hook up with the 5x squared. So 5x squared plus 1 times x plus 3. Okay? Don't leave this off and go, oh, it's just 5x squared times x plus 3, which is a common mistake. But if you think about it, that's only going to give me 2 terms, not 4 terms. So beware. And that's it.